Okay, YouTube, this is my first video in a module that I'm doing on solving trigonometric equations. And essentially what we're going to do is start with the fundamental notion of what a trigonometric equation is and what it is that we're looking for, but also talk about how we list solutions and kind of how we either restrict them or don't restrict them at times. So let's go ahead and start with recognizing what a trig equation is. We say that a trig equation is an equation that contains any trigonometric expression that also has a variable. So, for instance, we have sine of x here. This would be a trig a function with a variable inside of it. If I said, sine of x equals 1, this would be an example of a trig equation. So we've seen some equations that are true for only, or for any values, excuse me, of a variable, such as sine squared theta plus cosine squared theta equals 1. These types of equations that we've explored in the past, we refer to these as identities, and those are not going to be the type of equations we discuss in this video. As a matter of fact, in this video, we're going to be considering trig equations that are only true for certain substitutions or certain values of a variable. And what we're going to do is we're going to say that we call these conditional equations. We've seen things that are conditional before. We just say that these are equations only true under specific conditions. So we have here our very first trig equation, and this is basically the trig equation sine x equals a half. And what I'd like to do is really just solve this trig equation right here. So essentially, the question really becomes, what angle can we take the sine of and get a half? And if you know your unit circle here, we could at least, we know the radius of the unit circle is 1, and we could fill out all of our angles in the first quadrant here are pi 6, pi 4th, and pi 3rds, or 30, 45, and 60. But these all have something in common here. As a matter of fact, over here at our 30, 45, and 60, they're all over 2. So I'm going to go ahead and fill these out here to the best of my handwriting ability. We have 2's on the bottom, then we have 1, square root of 2, square root of 3. Up the right side, we have 1, square root of 2, square root of 3. And then, of course, we have points like 0, 1, 1, 0, 0, negative 1, and negative 1, 0. Now, I'm not going to fill out the rest of this unit circle. The reason why, though, is because basically you can see how all of these other points in the other quadrants are just going to be mirror images of what you see up here in the first quadrant. It's just that we may have negative or positive x values depending upon what quadrant we're in. So pretty obviously, we could say that solution to sine x equals a half, where would our sine values be equal to a half? We'd say at this angle right here, and this is our pi 6th radian measurement here, or 30 degrees. So we can see that our sine value is a half there. So we could say that x is equal to pi 6. The thing that I want to argue here, though, is essentially this. We say, well, is pi 6 the only solution for this? And because if you were to look at this here, we'd say this point over here would be a mirror image of what we have over here at 30 degrees on the right, except for the x value would be negative here. We'd have a negative x value. You could see also, though, that we get a sine value of a half here. And so in terms of what we get for an angle there, we can see that this would be a pi 6th measurement short of a pi radian rotation. So this is 5 pi 6th, and that would be another solution to this here. And I'd also like to make the argument that if 30 degrees is a solution, if we were to say 30 degrees plus another 360, that'd be 390 degrees. That'd be a solution also, or we could call that 13 pi 6 and so on and so forth. The idea is that we're going to be solving these equations for angles, essentially, that make this statement true. But at the same time, I want you to recognize that we get infinitely many solutions for the solutions to one of these. So when you look at this graph here, what you actually see here is the graph of sine of x. We have a graph that has an amplitude of 1 and a period of 2 pi. I can even put this 2 pi right here. We'd say that the halfway mark would be pi. But what we're seeing is a situation where we say, well, what were the solutions where our graph was equal to a height of a half? And so what you see here is the line, the horizontal line, y equals a half. And you can see that it intersects our graph infinitely many times if we were to stretch this from left to right. So there are infinitely many angles that satisfy this equation, sine x equals a half, and pi 6ths and 5 pi 6 were just 2 of them. So in order to list all infinitely many solutions to an equation like this here, often what we do is we'd say, let's choose our initial solutions here between 0 and 360 degrees. So within one full rotation, which angles would make this true? And so I would say that we recognize that pi 6 and 5 pi 6 were the two angles between 0 and 360 degrees, or 0 and 2 pi, that made this equation true. It's just that in order to list all infinitely many other solutions here, the interesting fact is that our sine equation has a period of 2 pi. And so because it has a period of 2 pi, that means that if we have a solution at pi 6, then what we could do is we could just say, well, going through another 2 pi cycle here, what you do is you get to another solution right here. And so what we get is pi 6th, and what we could do is add on the period length here, 2 pi. What we really get is pi 6th plus 12 pi 6th and 12 pi 6 plus a pi 6 is equal to 13 pi 6. So generally speaking, what we could say is this: if we were to take these initial values, and these are the values between 0 and up to but not including 2 pi, and we were to add on the period length to them, then we would have to land at another solution value. So in general, what we're going to write is pi 6 and 5 pi 6 because they were the solutions within one full rotation, okay? And then what we'll do is we'll add on multiples of the period here where n is just an integer value. And so this entire video, essentially, what we're going to be doing is just finding angles for which these sentences become true. And so what I want to do is look at 6 really pretty simple equations that we'll start with here and talk about what we get for solutions and how we want to report them. So in this first set here, we say, go ahead and solve the following trig equations on the interval from 0 to 360 degrees. So one thing I want to report about this is this: we want answers in degrees. The first thing we want to admit is that because they say on the interval from 0 to 360 degrees, we want our answers to be in degrees, okay? And also that we're only finding solutions that occur within one full rotation. So when we look at this first equation here, sine theta is equal to root 3 over 2, we say, what would theta have to be equal to? Just considering our unit circle, we would say that if sine is equal to root 3 over 2, essentially what we get is some sort of 60-degree reference angle. So because we know what kind of a reference angle we have, what I'm going to argue for us to do is essentially sketch a picture of our angle here in standard position. So with sine of theta being a positive root 3 over 2, and knowing that our sine function is positive in the first and the second quadrant, what we're going to do is we're going to sketch in one angle here in the first quadrant that has a 60-degree reference angle. And then we're going to sketch in our other angle here that terminates in the second quadrant that also has a 60-degree reference angle. The interesting thing here is the angles that we're after, though, have to be between 0 and 360 degrees. So what we're really asking for is, what are these angles when we draw them in standard position? So we knew that sine theta came out to be root 3 over 2 if and only if it had a 60-degree reference angle. And we know that sine's positive only in the first and second quadrant. So looking at these here, then we'd say, well, theta then has to be 60 degrees, but theta also has to be 120 degrees. These would be the two angles on our unit circle in which our sine value here, we could draw this in here, negative a half, root 3 over 2. These are the two angles on our unit circle where our sine values come out to be positive root 3 over 2. So looking at our letter B here, you'll notice that we have a reciprocal trig function. And of course, because this is the same thing as 1 over the sine of x, what I'm going to have everybody recognize is essentially that we could reciprocate both sides of this equation and still have equality. So the first thing you want to do, if we have something that is a reciprocal trig function, is we're going to reciprocate both sides of this equation and basically admit that if cosecant is 2, then sine is a half. This is much more desirable because now we can assess the situation and say, well, you know, what angles would give us a sine value of a half? Looks like it happens at pi 6, there's 30 degrees, and it looks like it would also have to happen over here with this 30-degree reference angle. So if we were to sketch this in, essentially, we know that sine can only be a half if it has a 30-degree reference angle. And we know that sine is only positive in the first and the second quadrant. So again, here's what we're doing. We're sketching in angles that have 30-degree reference angles in both of these quadrants, but then going back and asking, okay, so what are these angles if we discuss them in standard position? So our two x values here that make this true would have to be 30 degrees, but also 150 degrees. And these would be the two angles between 0 and 360 that make this statement true. So looking at these second two equations, really kind of the same thing that we're doing, except for what I want you to notice is that the directions say that I want to solve these equations on the interval from 0 to 2 pi. So this means that we want answers in radians this time. So a bit more quickly this time, let's go ahead and take a look at this. We say cosine of theta came out to be negative a half. Now with respect to cosine being negative, we'd say what quadrants would we have to be in? So we'd say all students take calculus. First things first, cosine being negative would mean that I couldn't be in the fourth and I couldn't be in the first. So we have angles that are either terminating in the second or the third quadrant. And we say that cosine came out to be a half. So now referring to the unit circle here, just reference angles wise, we could see that cosine is a half at a 60-degree reference angle or a pi thirds reference angle, third of pi. So what we're going to say here is this. We know that we have an angle that terminates up here and has a pi thirds reference angle right there. But we also know that we have an angle that terminates down here and has a 60-degree or a pi thirds reference angle. So here comes the question of the day, really. We'd say, so what are these angles in standard position? So we could see that this first angle up here is a pi thirds short of pi, or 3 pi thirds. So this would have to be theta as 2 pi thirds. And then we would say that this angle down here in the third quadrant is a pi third past pi, or 3 pi thirds. So we would say that must be 4 pi thirds right there. So looking at this next one here, another one, except for this time we have a tangent function. So now referring back to our unit circle, our tangent functions, it's certainly good to know that you can take your sine divided by your cosine and get your tangent values. So we would say that, for instance, at a 45-degree reference angle here, we get root 2 over 2 divided by root 2 over 2. We get a tangent value of 1. And I'll say that I'm going to list these on the outside here, but it's good to be able to find those. You need to be able to find those by taking your y value at any given angle divided by the x value to get you your tangent value. But these are our tangent values for our 30, 45, and 60 respectively. So as we look at this here, we say, you know, where does tangent alpha equal a negative root 3? Well, first of all, what would the reference angle have to be if tangent's a root 3? And it looks like it only happens at this angle up here at a 60-degree reference angle, or a pi thirds reference angle. So here's what we're going to do. Again, we would say it's a pi thirds reference angle, and tangent came out to be a negative value. So essentially what we're going to do is assess what quadrant we had to be in. If tangent's negative, then we couldn't be in the second or the first. And we would say, having a 60-degree reference angle, or pi thirds reference angle, we'd say here's our reference angle right here is pi thirds. But also down here, okay, here's our reference angle right there. This is pi thirds. Essentially what we want to be finding are the angles in standard position. So again, what we see is another instance where we get 2 pi thirds here. But down here, this is a pi thirds short of 6 pi thirds, which is 2 pi. So we would say that this is a 5 pi thirds radian measurement. So alpha is 2 pi thirds and 5 pi thirds if we're giving the answers in radians between 0 and 2 pi. So now looking at these last two, what we're going to be doing is, you notice the instructions say here, find all real solutions of the equations here. And so what we're going to have to say is, what we're going to start by doing is, 1, find solutions between 0 degrees and 360 degrees, okay, or 0 and 2 pi. And then what we're going to do, step 2, is add on multiples of the functions period. Functions period. And that's possessive. Guess what I mean is that sine, cosine, tangent, and cotangent all have a period of 2 pi. The only graph that doesn't, or function that doesn't, is tangent and cotangent, and they have periods of just pi. So as we look at these last two here, we want to report all solutions. Let's start with this. If we know that secant of x is equal to 2 root 3 over 3, then we know that the cosine of x, if we list this out here, would be its reciprocal. So 3 over 2 root 3, which as we rationalize this here, take the top and the bottom times the square root of 3, we get 3 square root of 3 all over 2 times 3 times 3. Root 3 times root 3 is 3, pardon me. So we get these to cancel, and essentially we get left with this. Cosine of x is root 3 over 2. So to solve this, we're really going to ask, what angle do we get a cosine value of root 3 over 2? What reference angle? We can see that cosines are x values here. This happens at a pi 6th reference angle, or a 30-degree reference angle. Okay, so we would say that x would have to be 30 degree in terms of reference angle. When we sketch this in, though, we would say that, you know, where cosine is positive, all students take calculus. I got a little ahead of myself here. We'd say that we'd have to have a 30-degree reference angle in the first quadrant or the fourth quadrant. So knowing that these are both 30 degrees right here, the question is, what in standard position are these angles? And so we would have 30 degrees, but also here's the other one, 330 degrees. Now because we're reporting all infinitely many solutions here, I'm going to write this a little bit different here. We say all of them. Then what we're going to do is we're going to say not only is it 30 degrees and 330 degrees between 0 and 360, but also plus any multiple of its period here, where we have 360 degrees times n. Or had we done this in radians, we could have said pi 6th plus 2 pi n and 5 pi 6th plus, oh, sorry, this isn't 5 pi 6th, this is 11 pi 6th here. So we have 11 pi 6th plus the period length multiples, okay? So looking at letter F here, this is the last one. We say where on the, you know, in the, what angles of theta would cotangent equal 0 is what I mean to ask. So we'd say, okay, so tangent of theta would be the reciprocal of 0. Now the interesting thing about this is that we could say, well, that is undefined. And you know what, I'm actually going to write 1 over 0. Because when we look at the unit circle here, we say what angles between 0 and 360 will we get 1 over 0 for tangent. So we know this has to happen at a quadrant angle, and because tangent is always sine over cosine, we could see that we would get 1 over 0 here, but also negative 1 over 0 and undefined here. So our two angles here are pi halves and 3 pi halves that are between 0 and 2 pi. So our two angles, we could say theta in degrees would be 90 degrees and also 270 degrees. The interesting thing, however, with tangent is that we have to add on multiples of its period. And in this case, tangent only has a period of 180 degrees. That is the exception to the rule. We'd say tangent and cotangent only have a period of pi or 180 degrees, whereas sine, cosine, secant, and cosecant all have periods of 2 pi. So we could also have said this here. We could have said pi halves plus pi n and 3 pi halves plus pi n.